understand? So whenever, at least with these two containers, we ran a container, correct? So if you're running a container, it should be running. It should always run. Why this container got stopped? If you want, you can definitely, but practically speaking, why it is not running? It is running definitely and it's completing and that's all. Why it is not staying there? So practically speaking, look at this. Do you know batch files, .bat or .batch files in Windows, right? Those are just kind of an executable files. So let's say if I create a batch file, look at it. I'm just creating a batch file, ABC, or let's say I'm just creating right from here itself, new file, and I'm just giving it abc.bat, or let me just create it through Notepad. All right, look at it now. What command I'm just typing in? Very simple, dir. What does this command will do? dir just like ls in Linux, right? So I'm just saving this and I'm saving this file with this extension abc.bat so that it will become an executable, right? So save that. And do you see this bat file now here? You see? Okay, now look at my screen carefully. As this is bat file, it's an executable, correct? So if I double click it, it should run, right? So let's say if I execute it, is it getting executed, guys? What do you think? Yes, but it should stay, no? Just like, let's say, understand what I'm trying to explain. This tool, we double click on it and it is running. So as it is running, you can see this draw.io in front of you, right? So just like that, why this executable is not stays running? It is just vanishing. Why is that? Because definitely we didn't give anything. So what it is doing, as I am trying to execute it, so it is executing. And what does this contains? What instruction this contains? So this contains only instructions to list all the files in the current directory, correct? Look at this. So if you open it up with Notepad, do you see? That's the only instructions we have given. So it is successfully executing and the instructions is only listing the files. That's all. It's completing. And is there anything else for this process to do? Nothing. So it's completing the execution, right? However, if you add something else, let's say pause, another command. Now look at it. So if you run it now, do you see? It has executed the first, and as you have given pause, it's waiting here. As soon as you press any key, it will go away because there is now no other commands to execute. Do you understand this? Okay. Now, just like that, when we executed this docker run hello world, that image, what does that image has? What does you think this image contains? This image contains only instructions to print this. Maybe through some piece of code or something like that, right? It is printing these instructions and that's all. There is nothing else in that image. That's why your container is not running. It's completing the execution and it's exiting gracefully. That's all, right? So if you want to keep your container running all the time, what does it mean? It should have some certain process to run. It should have at least one process to run. That's when it will be running. Yes or no? Correct. So if you want, you can manually also add some certain process to run, or there are some certain containers which already had some processes which will be always running. For example, nginx image. That nginx image is what? Is basically a web server. Or Apache image. What is that image? It's basically a web server. So if you are using these images, then definitely by default they will be running because it has, those images has one process, at least one process which will be always running, which is the Apache itself or the nginx itself, the web server itself. And images probably normally be just, if you want to keep them running, okay, you can just have your own process or your piece of code running in that. That's what about it. Okay, so now let's say go ahead and look at it. Let's say, for example, you see the output of your docker ps, right? You see this name. So okay, container ID is something which is auto generated. right? By default, automatically it will generate a container ID and it will assign randomly generated container ID for your container. But what about names? So these names are basically, if you don't give a container name, then by default, Docker will assign any funny name to your container. Okay, any funny name. Now, if you want to give a name to your container, then how you can give? So whenever you are running or creating a container from using, let's say, Docker run, then just use this switch, let's say -- name, and give the name of the container. Let's say I'm giving test as a name to my container, and obviously the name of the image itself. And if you want, you can also specify a tag. Okay, but you know now, if you don't specify, it would be by default latest. So now if you run a container and look at your images now, do you see how you can name your containers? Okay, generally it's recommended thing so that you understand this particular container, what does it contains. Okay, got it. Now let's say I want to remove this all containers, then how can I remove it, guys? RM, so Docker remove, either use name of the container or ID of a container to remove. So let's say I am specifying all the IDs here using and names as well. That's fine. And now if you see Docker ps-a, you see all the containers are removed. Okay, removed means what? Are they like deleted permanently from my machine, or it's just removed? It will be completely gone. Okay, and once it is deleted, there is no way to get them back. Right? What does it also means? So this container might have some certain data. Let's assume this would have been database, right? This would have been a database. Then definitely this image, from whichever image you might have created that container, that will have some data, that image will be there. Okay, but your application might have populated some records in your database. Assume this container, one of the container, right? And if that container is gone, then what does it mean? Container got deleted. But what happened to that data, which your application might have stored in the database? Lost, completely lost. And there is no way to get it back once the container is gone. That's why we call containers are volatile. If it is gone, it's gone, right? So what can you do then? You can definitely launch a new container from the existing image. But again, that image, will it contain your data? No, it was just a fresh one, right? Your container will get launched from your image and it will contain only things which your image will have. Why we call containers are volatile? Then second thing. So these images, all these images, let's say if you delete your container, then what happens to image? That image, is it still there or it will get deleted? So practically speaking, have any one of you have ever installed operating system on your machine or know how to install it? Okay. How do you generally install an operating system? Either from a pen drive or probably a disk, right? Or basically from an ISO image. That's how you install, correct? Once you install an operating system on your machine from an image, from an OS image, after installation, does it has any correlation with the image and your system where you have installed your operating system? Any correlation? Not at all, correct? Just like that, once you launch your container from the image, there is no relation of that image and that container. Now both are two separate entities. And just like that, you can use one image to create lots of containers, just like we created with Hello World. Okay. Also, containers are volatile in nature, but images are immutable in nature. What do we mean by immutable? Immutable means something which cannot be modified. Okay. So let's say you have created an image, let's say image version 1 now for your application, and now you want to deploy a new feature. So if you cannot modify the existing image, what you can do then? You can create a new image with, let's say, version 2. And just like that, there will be multiple versions will exist eventually. Correct? So that's exactly why you see, if you open up any image repository, you see why there are so many tags, because those images has been created. I mean, this image has these many versions. So now let's go ahead. Let's say just like we have this hello world image. Now tell me one thing, guys. Let's try to run another image. Let's say, let's run CentOS. Just like this, docker run hello world and colon, whatever tag you want to specify. Copy whatever tag you want, just like this. Now let's run another container. Let's say I want to run this CentOS. Okay, so you see this CentOS, right? This is an operating system, let's say. Now I'll do this CentOS. So how to run? Very simple. Docker run CentOS. If you want any specific version, go to tags, copy any specific version. You see, this is the tag, CentOS something, or even CentOS this, CentOS 7. Okay, just go and run this :7. This is the tag. Okay, and you see this image is not available locally, so it is pulling up, it's done, and container is running. Perfect. So if you check it now, docker ps-a, you see it's again gone. And why is that? Now you know the reason, correct? Why? Because this container, when we ran, does this container had any process to run? No. So it's gone. There's nothing to run. As simple as that. So now how can we keep this container running? So this much is clear that CentOS image does not have anything, right? No process, nothing. All right. So what can we do is we can add a process. So how can we add a process? Very simple. So when you are running a container, let's say docker run, what you can also do, just like you can give a name using this tag, let's say OS, the name of the container, right? And you can also specify what command it should run or a process should run. Okay, which process container should run. Okay, when I'm saying process, what does it mean? We mean an executable thing. So it means an executable thing, number one. And number two is whatever process or whatever executable thing you want it to run, that should be present in this image. Yes or no? Otherwise, how could it run? Perfect. Now, what I'm specifying, let's say I'm specifying bin sh or bin bash. I mean, I don't know that, okay, which all things this CentOS 7 has. So, but definitely it will have a shell. It will at least have a shell, right? So I'm saying run the shell. All right. Okay. So if you execute it, okay, it already was running a shell. Okay. So what I will do, I will just mount it. So let's say if you want to get into a container, use this -it interactive and give another container name OS1. And now do you see the shell is running, and that's why it took you within the container. Basically you SSH into a container. Do you see this? Your prompt has been changed. You are no longer on your EC2, you are within a container, right? Cool. So behind the scene, what is happening? Your container is running and you ran that container like as an in the IT stands for interactive mode, and you have given this shell. So what has happened? You have window. I mean, that shell is running in a window, just like your this terminal, right? This CMD, just like it's getting mounted on a window, and that's why you are into a container now. So as soon as you say exit, meaning what? This process will be terminated. I mean, by exit, you are terminating your shell, right? So as soon as this process get terminated, now your this container, OS1 container, does it has anything to run? Nothing, right? Because you terminated it now. So you see now, if you say, do you see this OS1? Now it got terminated as soon as the process is gone. Okay, now what does it mean? Can't we just keep it running? Definitely you can. So what you can do, whenever you are running a container, let's say in this similarly something like this, so you can use another switch, which is -d, meaning what? Run in the background, run in the daemon mode. Okay, -d, run in the daemon mode. Look at it now. So you see, now if you say docker ps, do you see your OS2 container? Now it is running, right? And it will keep running till the time you have this process running within this container. You see, this will be running. Okay, now let's say if you want to now execute some certain things on this container. How you can execute? Let's say you want to execute some command on this container. What command? Let's say I want to SSH into this running container. I want to see what's happening. I want to see what is there in the container. So how can we give it? So we can use docker execute, right? So let's say I'm saying execute this command. Which command? Let's say execute in an interactive mode and on this container OS2. And which command we want to execute? I'm saying same, bin sh. And as soon as you execute this command, you see you are now within a container. Now you can do ls, you can see what all things are there, right? However, if I do something like this, clear, it will clear the screen. Let's say I am executing something else, sudo yum update. Let's say, you see what it says? It says there is no command like sudo. Okay, let's say I execute nano. Oh, no nano, vi abc. It will open up a vi. Let's say ping. Okay, ping command, it has only yum update if I want to check. Oh, it is saying there is no valid base URL. Alright, let's try to install something. Nano. Oh, nothing. So why I'm telling you, let's say despite this is an CentOS container, is it a full-fledged operating system? No, it is not a full-fledged operating system. Then what is this CentOS? What does this image contains? It contains only required things in according to give you the flavor of CentOS, the minimalistic version.